This is my twin-cylinder two-stroke boxer engine which I made from the ground up for my bicycle. In the last two videos I showed in detail how I made the crankcase and the crankshaft. In this video I show you how I developed all the remaining parts of the bike. Specifically the exhaust setup, the intake system and the engine mount. I developed this boxer engine because the crankshaft of my 3-cylinder engine setup I had previously installed snapped. To make room for the boxer engine, I will now remove this broken 3-cylinder engine setup so I can start with the development of the engine mount. So now that the 3-cylinder engine setup has been removed, I can start on the engine mount. Since I might want to swap this 2-cylinder boxer setup for 4-cylinder boxer setup in the future, and I don't want to weld engine mounts onto the frame, I've opted for these mounting shells again, just as I did for the 3-cylinder setup. For the first prototype I chose the length of the shells only roughly. This adapter sits between the engine and the shells. The length of these two adapters allows me to fine-tune the motor's end position very effectively. So I printed 3 adapters for different length, one 10mm long, one 15 and one 20mm long. After that I tried out every adapter length combination at the front and rear until I found the motor position that was perfect for me. Based on the adapter length I had determined, I decided on the length for the front and rear shells and printed the first prototypes. After that I mounted these brackets onto the engine and installed it in the frame. Once the engine was installed, I discovered that a fin on the cylinder head was hitting a reinforcement I had welded into the frame. So I removed the cylinder head and clamped it into my milling machine to mill off the fin. Once the fin was removed, the motor fit perfectly into the frame. Next I tackled the intake system. Ever since I felt and saw the huge different reed valve made on my 3-cylinder 2-stroke engine, I really wanted to have them on my boxer engine as well. This engine even needs reed valves even more because the positive and negative pressure inside the crankcase is greater than on a single-cylinder engine. So I considered which reeds I should install. Then I came across the TU reeds. They are nowhere near as expensive as the AM6 reeds with my custom housing on the triple setup, and they are also used by many people in the motorized bicycle community. So I got myself a few of those. I held one of them against the lower cylinder intake and realized they were significantly larger than I had imagined. My idea would have been to make a small, short reed valve adapter and position the carburetors facing sideways. But unfortunately, that won't work because the rear engine mount is significantly in the way. Then I considered other ways to mount the gear reeds onto the cylinder, because I really want to use them. Then I had the idea of positioning the reed valve housing at a specific angle relative to the intake and having the carburetor pointing straight towards the rear. I wanted to keep the adapter as short and compact as possible. Then I printed the first of many prototypes to get a feel for it and to see if and how it fits. However, I realized right at the start that I need to modify the rear engine mounts to make room for the reed valve. I then mirrored the lower reed adapter, and this second reed adapter is for the upper cylinder. This is also very practical, as I only have to design one part, since the other one is an exact mirror image of it. Next, I printed several prototypes and experimented with the two angles that made up this adapter. One angle determines the carburetor's tilt, while the other determines whether it points straight back or angles slightly outward. After printing many prototypes, I found the angle that fits perfectly. Both carburetors now point straight towards the rear and are tilted slightly upwards, and I am very satisfied with it. Next came a difficult task: the design. At first it was difficult for me to connect these two surfaces in any way and turn them into a solid body. Next problem was the 4 holes for the screws used to mount the gear reed to the adapter. These holes also required a specific depth, and in combination with the two angles, it was quite difficult for me to design a model suitable for milling. This was my first attempt. The adapter works perfectly, but I am not happy with the design. It's very bulky. This adapter was my next attempt. It is significantly slimmer, but this highlights the issue with the depth of the screw holes. I then explored the surface modeling tools and used the 3D fit spline to draw a very organic model, though I wasn't happy with the result. I then experimented a lot and these two models emerged. They are already quite close to the finished part. I then noticed that there is a lot of empty space between the gear reed and the adapter, which isn't actually needed. That's why I developed this filler piece to get rid of the unnecessary space. It took quite a long time and I printed many prototypes. The challenge was filling all the unnecessary space while leaving enough clearance for the gear reed housing. And this is the finished gear reed adapter for my BOXER engine. I incorporated pockets at the top and bottom because there was a lot of unnecessary material. I also incorporated a hole that runs all the way through the part, so you can see through the adapter from multiple directions. The part is admittedly complex to mill, but it looks really unique and I'm very satisfied with it. Next, I adapted the rear engine mounts to the reed system. First, I used an angle grinder to roughly remove material from the shell, so I would have a reference point for CAD. Next, I experimented and printed a lot of prototypes until I determined the perfect dimensions. The whole process was very time consuming and I printed more prototypes than ever before. Each one is slightly different, but only in the details, be it the exact position of the engine mount or the shape, size and depth of the cutout for the reed system. Then I had the idea of mounting the CDI on the rear engine mount. It's also the only spot where it looks good and where I have enough space for it. There's no room near the front engine mount, plus the exhaust gets in the way here. So I designed a small bracket for the CDI and integrated 2 screw holes into the motor adapter where it then gets mounted. In terms of design, I incorporated pockets wherever there was sufficient material. Additionally, the entire interior of the mount has been hollowed out. This design complements the intake adapter very well and I'm very pleased with how it turned out. This also fits the engine as a whole very well and fits the empty space here nicely. Next up was the exhaust. First, I zip tied 2 pipes from a KTM SX85 to the frame to get an idea of what it might look like. But I didn't like that. After that I used 2 KRM 8090 pipes the same ones I had previously installed on the 3-cylinder setup. I secured them to the frame using zip ties again. It looks a lot better with these pipes and they also fit the setup much more. Next I had to design the 2 exhaust flanges. The upper one was fairly straightforward, as it simply extended straight out. The lower one, however, was trickier. In the initial prototypes, it pointed not only downward but also slightly to the side. I experimented with various angles until I had enough clearance to the frame. Finally, I incorporated 2 grooves to hold a rubber ring, which prevents everything from getting covered in oil. Next, I set to work on the exhaust bracket. I began by roughly aligning the mounts on the pipe and determining the distance between them and my point 0. This gave me the approximate 3D coordinates for the mounting surfaces. Using these, I printed the first prototype. Once it was mounted, I saw that I needed to make slight adjustments to the coordinates. So I printed several prototypes to determine the perfect dimensions through trial and error. After determining the final coordinates, I set about the design. At first I found it difficult to combine the 3 points in 3-dimensional space with a design. This was my initial idea. I didn't like it. Then came this idea featuring 3 organic struts. But I also didn't like it. After that I experimented with what a 2-part mount might look like. But I didn't like that either. For the 4th version, I drew 4 twisted struts. I liked that best so far, and I was getting closer and closer to the final design. This is now the finished exhaust bracket, and I completely escalated on the design. The 4 struts are now straight rather than twisted, and the material between them has been removed so that they stand freely. Also, the mount is a single piece, unlike the 2-part design of the earlier concept. There are also 2 additional struts on the underside that provide stability. Furthermore, this entire section is hollowed out. This means you can see right through the part from several different angles. Milling this part will be a challenge and consequently expensive, but I want to have it exactly like this. I'm also pleased that the exhaust mount, CDI mount and D-reed adapter share a consistent design. You can tell the parts belong together design-wise. And with that, the whole BOXER engine setup is now finally finished. There were many problems during development, but I am happy with every single solution. I am also happy with the design of all the individual parts I have developed, even though I went a little crazy on some parts. Now I'm curious to know of what you think of the whole setup. Do you like it or would you have done it differently? So now at the end of this video, let's talk about a different topic, namely the problems I have with this engine. This is my 6-speed MXS twin-cylinder engine, and this is the jigs and are the crankshaft parts I made for this engine. Just like on the BOXER engine, I also started with this engine at the crankshaft. Only when the crankshaft is 100% finished, I will have the engine casings milled. But I have a few problems with the crankshaft that I'm going to show you now. This is what the crankshaft will look like once it's finished assembled, more or less. The cones on each side are missing, but you get the idea. The crankshaft is in principle very similar to the RD350 or Banshee crankshaft, because on each side you have the 2 crankshaft sections for each cylinder, and in the middle you have an intermediate shaft, and both sections need to be aligned exactly 180 degrees apart from each other, just like on a Banshee or a 2-cylinder Skido crankshaft. The first problem of this crankshaft is the precision. It looks pretty decent made, so that's not a problem, but if I grab the bearing that goes onto the crankshaft, this is an RD350 bearing. Back in the day where I was developing this engine, I thought an RD350 bearing would be absolutely perfect, suitable for this, because the crankshaft shares the same principle. And the problem is the fit. This should be a press fit. The shaft should be exactly 25 mm, but unfortunately it isn't. It is exactly 24.96 mm. And now you see it is not a press fit. It's just loose and I can't use this crankshaft. Unfortunately, also my clutch side has the same problem. And furthermore, they also forgot the thread that goes onto here. Otherwise, the halves are very decently made. I can't spot any marks from clamping the parts, but the precision is the problem. That also goes with the intermediate shaft and also the inner diameters of the inner crank halves. So this diameter of the intermediate shaft should be 0.06 millimeter larger than this diameter, but unfortunately it isn't. So now I have to have the entire crankshaft made again. It's not that great, but it is what it is. Because I get a completely new crankshaft anyway, I thought about my idea of how to perfectly align the two crank halves 180 degrees from each other. My idea regarding the assembling of the crankshaft would have been to first press in the crank pin into the inner crank web on both sides. After I had pressed in the crank pin, I would have put the bearing on the intermediate shaft and then I would have pressed this into the crank web. Then these two parts are solidly pressed together. So far so good. Then I would have placed this assembled crank part in between the two aligning shafts. Both inner crank webs share the same cutout, and with this cutout my idea would have been to help me align those two crank halves and press them together exactly 180 degrees. So this would have been my idea, but now here comes the problem, which is so now the lower crank web is installed with the previously installed crank pin and also with this intermediate shaft. You just have to think this would have been installed. And then next part would have been to press this crank web onto the intermediate shaft, which is then right here. The first problem is I can't get this crank web into the aligning pins. Then when I lose the pins, you can see now the upper web is in between the two assembling bodies and the lower one have massive play. I don't know why this happens, but I guess the machining is not that precise that I was hoping it to be. So at the top it's a lot more narrow than at the bottom. And when I press this down, it's also completely loose at the bottom. So all of the parts you can see here now are a complete waste of money. And not just a bit of money, I mean a lot of money. But yeah, now it is what it is. The only good thing is I made a new base plate because the original one, it was made of very poor quality. This part fits well and I'm very pleased with how it looks. And also these two cones I made have the right dimension. You can see they fit pretty well and that's good because my measurements are correct. But otherwise this is just a complete waste of money. And because I need a complete new crankshaft, I was thinking about of deleting this groove in here. Because pressing the crankshaft together with this style didn't work, as you see. My question is now if anyone who watched this video till now have made some experience in assembling a RD350 crankshaft or an Skido crankshaft and know exactly how to align these two crank webs exactly 180 degrees apart from each other. I saw Alan Milliard use the lathe method for building his 4-cylinder Kawasaki crankshaft, but in my opinion this isn't that precise. Unfortunately, Yamaha or Hot Rods doesn't tell me how they align their crankshaft. I would be more than happy if someone would tell me how to perfectly align those two parts 180 degrees from each other. I already have one or two ideas, but I'm not yet entirely convinced by them. But I think I will figure it out somehow. In the last video I talked about the problems I currently have regarding the manufacturing of the parts, and a few people contact me, and actually one of them is currently making the BOXER parts. And because now I have to wait until the parts arrived and I also have to think about what to do with this crankshaft, I now got bored and started on a little side project. Let me show you really quick. So this is an AMR 300 supercharger. I have a place for this in a future project. Then here's the MXS Twin. I bought those cylinders because I have a little bit of a shopping addiction. This is an L2, but unfortunately the original deck height wasn't sufficient enough, and both cylinders are now hitting each other, and I don't know what to do with the cylinders, but they were not too expensive and are from Rotax, and one of them makes around 70 horsepower, so that's nice. But I have to think about what to do with them because this current setup, as you see, doesn't work. And I also have a second V2. This was the previous version of the Rotax L2. And the idea was to have a boat style crankshaft. I've also bought a boat crankshaft, you see, with those intermediate plates and those sealant rings, but that's way years in the future. And I also want to make something out of this bike because it's just sitting in here, and every time I look at it I just thinking about how beautiful this bike is. I mean, really, it's so stretched, it's so low, absolutely beautiful bike. My rough idea was to put this engine inside the bike, but then a few problems arose, and then I bought those cylinders and thought about this solved every problem. It doesn't. Today my tires arrived I bought. These are motorcycle tires. The idea is maybe to put them with new rims on the bike, but I don't trust the frame, and maybe I build everything completely new, but I don't know yet. Now I make some thoughts about the crankshaft, and yeah, stay tuned and see you next time.